All right, so question is, when creating PDF, and you're at home, right? Adobe PDF is a purchased software, and so it's not available in your list of options as a printer when you're at home. So Control P. So if you are at home, this won't show up, right? If you're at school, I would probably tend to use it because it makes the paper selection pretty easy, right? And it's Adobe product, works great. But if you can't do that, then you have the DWG, AutoCAD DWG to PDF, this option right here that you can use. And this one looks like it's this one is new, AutoCAD PDF. I'm sure that's going to do the exact same thing, right? I don't know if I could tell you the difference between which one's better or worse, right? Let's try one of these. Let's try AutoCAD PDF, general documentation, right? So we would choose ArchD, which is 24 by 36 or 36 by 24. I'm not going to, well, I'll go over how to scale it in a second. I just want to see what the printer does. Let's see. We'll choose that one, preview. I mean, we do get a PDF, right? So we'll print that, desktop, save, and we do have a PDF. So the AutoCAD PDF, general documentation, great. That seemed to work pretty well, right? DWG to PDF, that's going to work. That's what we've used forever to get PDFs. So that will work. And then when you're here, you can use the Adobe PDF to create it. Again, maybe I should Google that, right? Quality PDFs, but I assume they're all going to be fairly similar. Yeah. Any other questions on printing at all? Okay, I'll go over how to, I want to go over how to print. You know, you guys were working with these last week for your assignment. So I just want to go over one and just briefly remind you how to print from AutoCAD from model space. Of course, this is kind of the fast way of doing it. We will learn how to print from what's called paper space pretty soon, but it is good to know how to print to scale from model space, right? When you're very quickly need to print something. So let's look at this. Let's print these stairs, okay? Now, before I even get to the stairs, I want to bring up the topic of your pen file, okay? And I want to remind you of a couple things. If I open up my layer manager dialog box here, you'll notice that we have all these layers created, right? And we have color associations with those layers. And I said before that in AutoCAD, we have a color-based line weight system, okay? And that means that the colors represent a thickness of pen when we, a thickness of pen when they're implemented on the screen. So if I assign, for example, red to a layer, in our world, that means red is a very thick line, right? And we know that. And if we assign a white color to a layer, then that means that that line, if we use that layer, will be very thin. And we've kind of talked about, line weights are pretty important. They distinguish different things in drawings, right? So in a floor plan, the heaviest pen is always the cut line, right? So where we take that horizontal slice, that horizontal slice across the floor plan, all those objects that we hit, those are very thick lines, right? And we have 3 different thick lines: heavy thick, medium thick, light thick. And then we have the medium pen weights, which are those objects between the cut line and the floor, right? Furniture, equipment, millwork, stairs, things like that, okay? And then we have the light pen weights, which are going to be hatches and things furthest away from you in the cut, right? It's a field of vision. Things closest to you and things furthest away from you. Now, that same rule sort of applies to things like this where it's a sectional view. A section is going to be a vertical cut of an object, like a building or, in this case, a stairway, all right? And the things that are going to be cut, like the actual stair and the floor slab and maybe the railing, those are all going to be very heavy pen weights, right? Then we have the medium, which are going to be medium detail items, and then light, which are hatches and things furthest away from you. Morning. That's okay. I figured the rain is probably delaying, right?
Well, and unruly child this morning.
Oh, yes. I was just telling Kevin we also had one of those. So I left. My husband deal with his little mini. Funny. So the pen weights are pretty important because we want to be able to read the pen weights in our objects, right, in our drawings. In order for us to have our pen weights read, we have to use what's called a CTB file, a pen file. You'll hear those terms. Where are your pens? Where's the CTB file, right? And every office has their own CTB file, okay? The CTB file is located, I just want to remind everyone, if you go to this PC, and then you come over to CAD Common, okay? You go to, oh, it used to be, I thought just somebody took it. Arch, and we go to 1310, Drawings. That CTB file is right there. We'll put it at the top. I'm just going to copy it, and I'm going to put it back here as well. But this little file loaded into AutoCAD tells AutoCAD what our pen weights mean, what the colors mean, right? Thick, thin, light, fine, whatever, okay? The way that we're going to load that pen file is by right-clicking on it and copying it. And this is generally, I say generally because whoops. I say generally because in the lab things change a lot because there's so many people coming in and out, right? But in general, when you take this home and load it on your own computer, you have to do it one time and it's there forever until you reinstall. So right click, copy, and we're going to go to AutoCAD. We're going to go to File, Plot Style Manager. Okay, this is probably the #1 thing students forget. And then you're going to right click and paste it in here. So you paste it in here, obviously I already have it there, right? But that will make it so it's available to you in your print dialog box, right? So when I go to print, if your pen file, your LaserJet CTB is not there, that means you have to go and get it and load it just like we did, okay? Yep. Yep. So you're just going to go and you're going to find it on CAD Common. Sorry, let me go to, which it's right there, right? Right click, copy. And then we're going to go to File. And if your file menus are missing, which sometimes they are at home, right? Because it's not a standard way of AutoCAD looking right out of the box, you can click this down arrow and choose Show Menu Bar. Yep. You're going to go to File, Plot Style Manager, right click, and paste it. And that's all you have to do to load it. That's it. Yep. So once you've done that, you have the pens available to you, right? So now it's just time to print this object. And the first thing that we're going to do to print this object from model space is we're going to measure it. I like to measure things kind of visually so I can see what I'm measuring. I'm going to draw a line across this that, you know, goes slightly above here, slightly out to the side, right? This goes slightly out to the side, slightly below. I'm going to measure that line, distance. And it is 20, we'll say 21 by 21. Let me write this down. Oh, one piece of scratch paper is missing. It's 21 by 21. Okay. I go to the very last page of my book. Well, yeah. Second to last, very last. The plotting and text size and scale factor chart. And this one says on 8.5 by 11. We want to use an 8.5 by 11 inch piece of paper. So I go down the left hand side, I find 8.5 by 11 inch piece of paper. I go across to the right, I find a piece of paper that will fit a 21 by 21 foot image or drawing, and that is 3/8 of an inch. This could probably be a little smaller. I'm wondering if we had some 1/2 inches. Well, either way, it doesn't really matter. But we have 22'8" by 29'4". So that is the size of the next operation that I need to do, which is to draw a rectangle around this object, right? These sizes that are on the scale factor chart, those are perfect increments of an 8.5 by 11 or 11 by 17 piece of paper. And so that's why we have to That's why we have to change the size, right? You say, well, a 21 by 21 inch square or foot square will fit, but we want an increment of an 8.5 by 11 or 11 by 17. So I'm going to draw a rectangle around this, click, and I'm going to type at, because this is a relative input, 22 foot 8, 22 foot 8, comma, 29 foot 4, enter, and I have my rectangle around that. It's a little off center, so I'm going to M for move, and I'm going to move it just a tiny bit. It doesn't have to be perfect around it, right? But just so it's somewhat centered. Okay. When I chose that 22 by 29 foot rectangle, if I look at the top of that column where I found that in my book, it says that the scale factor is 3/8 of an inch or 32. So when I print, right, I'm going to choose my PDF, and just for fun we'll choose AutoCAD PDF, right? And we will choose a letter size, 8.5 by 11. It's probably all the way at the bottom. Nope, yeah, there it is, 8.5 by 11. And our what to plot is going to be a window. Bumps me out. I click, and define that window area. Now center the plot. I'm going to uncheck fit to paper, and I want to choose my scale as 3/8 of an inch is equal to a foot. Couple more things I have to check. Number one, I need to make sure that my pens are chosen right here. If my pens are not chosen, then I won't get any line weights. They'll all be the same dark, thin line weight, and we don't want that. And I want a portrait view, so I'm going to, I've got everything looking good, window, ANSI, my printer, okay. I always preview just to make sure everything looks good, which it does, right? And I hit okay. Now this is a PDF, and of course a PDF is a digital file, and so I need to save that PDF somewhere. So I'm going to go to my AutoCAD homework folder, and we will call this layout assignment. Looks good, right? And I look at this and I see my line weights reading, right? I see a very thick pen weight around the cut of that section. I see that this detail on this railing is thinner, right? I see that the hatch is very light and gray tone, so it all looks very graphically correct. All right. Okay, any questions about that? Any printing questions at all? Pretty good? Okay. All right. So let's talk about, I'm going to talk today about polylines and pedit and LT scale. Make sure. Okay. And I think I'm just going to, there's a file that is called polyline_polygon. And I'm just going to I've opened that up obviously. And that's what I'm going to work with for right now. And I think the best way to describe a polygon is to describe it in terms of, or sorry, not a polygon, a polyline is to describe it in terms of a line, right? In AutoCAD, you've probably kind of gathered this already. There's a lot of different ways to do the same task, right? So if I want to draw a rectangle, right, I can come up and click on line. I can draw 4 lines. Great. If I want to use the rectangle tool, I can use that. Great. Okay. Now the difference between using a line and something like the rectangle tool, there's not a whole lot of difference, right? I get the same product here. If I draw a rectangle, looks just like that, right? So when I print these out, there's no difference. Okay, the only difference likely between these two is that, this object is a rectangle, and it is considered a polygon. And inherently, and you all don't know this yet, this is a polyline, okay? And so these lines, when I create a rectangle using the rectangle tool, they're all connected together in one piece, right? And that has some value. Even though one is not more correct than the other, there's some value in how they're drawn. This line, or this rectangle, is drawn from lines, right? And so each of those line segments that form that rectangle are all separate, okay? All right. So what's the value in one method over the other, right? I'm not saying one's right or wrong, but you know, one can help you draw a little bit and one can hinder you a little bit, okay? So with our actual rectangle tool that is a polyline, and a polyline means that I have connected line segments, they are all joined. So it's not just one piece, right? It's a bunch of pieces that are all continuously connected to one another. What's nice about this is that in the future we're going to learn some different tools, some tools like offset. And when I offset a continuous polyline, it offsets everything, right? And it's all continuous, and the corners are nice and squared off, and everything looks good. Let me do that, but with a smaller number. There we go. Okay. Now when I do that to a rectangle that is not polylines, can you see how, first of all, I have to go around to every single line, right? Which is fine, that's fine. But I need some more tools to finish that command because as you can see here, these don't quite meet, right? So I'm going to have to perform some more cleanup commands on those to make them look like a rectangle, which we don't know yet, right? So the value in drawing polylines in AutoCAD is that when you offset them or you copy them or you move them or you rotate them, you click once and you get everything, right? It's one cohesive line, all right? And when you use lines, when you offset, move, rotate, copy, you have to select them all, right? And there's value in each one, right? So sometimes when I'm drawing floor plans, you know, the lines are better for whatever reason. And you'll start to be able to figure out why one is better over the other, right? But for now, it'd be nice to know how to create and draw polylines so that when you do need them, you know how to draw them, right? One more quick example, right? I said when I draw floor plans, it might be nice. If I use the polyline to draw, which I'll talk about in a second, if I use the polyline to draw a floor plan, right, and it somewhat looks like this, we'll just do that, okay? What's nice about this is I can offset it, the wall, 4 inches or 6 inches, whatever this construction is, right? And I get an entire floor plan. And if I hadn't used polylines, I would have gotten some line segments that needed cleanup or, you know, whatever. Okay, so you guys can probably see now why polylines are a good idea. All right, polyline, line, great. Okay, so let's talk about polylines and how we can create polylines, how we can undo polylines, and then once we undo them, how we can join them back together. Okay, polyline is right here, and essentially a polyline it's a connected sequence of lines, right? So you can click, 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 click away, and regardless of how many line segments you click, as long as you don't hit escape in between them, they are all one continuous line. And so what that means is if you move it, every segment moves. If you change the layer, every segment changes. If you copy it or rotate it or, you know, delete it, then everything, you know, goes along with that one segment, okay? So if I click on polyline, it'll ask me just like the line command to specify the first point, the start point. I can input an absolute input, a relative input. I can click in model space and just get going. So I'm going to snap to here, click, move in the direction I want to go, click. Oh, I think I'm going to sneeze there. Ooh. Maybe not. Okay. And I just keep click, 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 clicking, click, right? And I'm creating a polyline. Now I can add dimension. So if I move in the direction I want to go and I type 10 foot, enter, you know, just like any other line tool, I get a 10-foot line. I move in the direction I want to go, I type 2 foot, enter, and I get a 2-foot line, okay? So this is in functionality and execution, it's no different than really the line command. I hit escape, escape to get out of it. I click on it, there it is. I hit M for move, and it all moves as one continuous line, okay? It's great. Okay, let me click on polyline again. I click on polyline. I'm going to draw it. We see this here, but I'm going to draw a couple of other lines up here real quick. You can see I can use my object snaps on it, right? I'm tracking. I can use ortho. I can turn that on and off, and I can use it. So really, you know, in practice, they're no different than lines, okay? So I have polylines, I have lines. The nice thing about a polyline is that I can generate a polyline and I can create one, and if I don't end up wanting to use the functionality of it being a polyline, I can explode it. Explode is a command we haven't learned yet, and it is right there, explode. And explode will take any object that you select and then perform that operation on and break it down into its component parts. So whether it's a block, which you don't know about yet, or some, a lot of other things in AutoCAD, if you want to break something apart and destroy its integrity, you explode it. Okay, so the same, I can use explode on this polyline, and essentially explode, you click on it, you initiate the command, you select the object you want to explode, click, and you hit enter, and it explodes it. And it explodes it from being continuous. So I have a line now, I have a line, I have a line. You guys get the idea, right?
Is there a way to put it back together?
There is, yes, and we're going to do that next. Yeah, there is a way of joining it back together, which is called pedit, okay? So we can go backwards once we have exploded it, right? My best advice is if you want to create a polyline, just create it in the first place, because polyline edit, pedit, is a little bit finicky at times. But there is a way to join it back together, okay, which we'll talk about in a second. So I can explode this and break it back down into its component line segments. I can polyline edit it back together and make it a polyline again. Not only can I take lines that I have exploded that were once a polygon or a polyline and bring them back, I can also take really any line segment and create a polyline after the fact using pedit. So if I create a bunch of lines and I think, oh, it would have been great if I would have just used the polyline command, I can go back after the fact and join them back together. Okay. So, you'll probably want to, practice using polyline. Again, it's not very different from line, but it's helpful, right? It's helpful when you're creating different line geometries. One other property of polyline that is really great is that we can create rounded corners well, you know what? I think this is not really, maybe he joined these back together. Hold on a second. I don't think we can use polylines to do that anymore. Let me just check. We might hold off on this one. Oh, I guess we can. Or did I use a line or a polyline? I can't remember now. I had some troubles with this. Yeah, it's not gonna, okay, we're gonna skip this for now. We'll come back to that in a second. Or when we learn a different command actually, because this is not gonna work anymore. All right, so let's talk about how we join polylines together once we break them apart using explode, right? And again, explode can be used really on anything. So if you, like I said, if you have blocks or other things that you want to break apart, you can use explode on them. All right, so polyline edit, the command is pedit, and I don't believe we have an icon. Let's Google it and look. But I'm pretty sure.
The join and it works in there under modify.
The join.
Yeah.
Under modify.
With the arrows.
Oh, this little guy right here.
To the left of it.
Oh, there we go. Okay. Let's see. Join. I wonder if it has all the same. It probably does the exact same thing here as polyline edit. Yeah, so it brings polyline. Okay, so here's going to be the difference between join. Join is kind of like a broken down polyline edit, right? So you can use join, but as I was just kind of thinking in my mind, I don't think it has all the options of polyline edit. So join will allow you to, and I think these are kind of, AutoCAD over the years has adopted a lot of kind of common commands from other softwares, right? Like some of them very specifically like from SketchUp, but I think they're trying to, people get used to commands in other softwares, right? And so I think they've integrated a few, like join is one of those probably here, and push-pull when we're doing 3D is another one that they kind of ripped off from SketchUp. So we do have some of these commands that people recognize. Essentially join, you can use join to create a polyline, but it doesn't have as many options as polyline edit, right? So you could use it just to simply join lines back together. So obviously it's here, right? We can go to modify, we can click on join, click, and you can select all of the lines that you want to join back together. And when you're done selecting, you just hit enter, enter. And you notice down here that 6 segments have been joined into one polyline, right? Great. So these have all been brought back together into one polyline, okay? That's pretty simple, very easy, right? So I think that that has its place and that it's just really simple to use. Polyline edit is great because it has a lot of options associated with it, right? But it is a little bit finicky at times. Let me explode that line and let's do a polyline edit. I'm going to type pedit, enter, and this will allow you to select, you know, multiple lines here. So I'm going to hit enter again to select multiple lines. I'm going to grab all the lines. When I'm done selecting, hit enter. And here is where it kind of veers off from join, right? Convert lines, arcs, and splines to polylines. I'm going to click on yes. Now I have a lot of different options that I can use on this polyline. And right now, join is actually probably a pretty good option for you because you're not going to use a ton of these, but eventually professionally you'll use these more often, right? We have join, okay, but we also have a couple of others. We have a width, we have close, open, and those are going to be pretty helpful for you. Today we're going to talk about join and we're going to talk about width, okay? So join, obviously, inherent, that's like the other command, is inherent in polyline. I can click on join, and it says, hey, you want to join? Enter a fuzz distance. We're going to just hit enter on that. We're going to leave it at 0. Yeah, it's basically like, it's kind of complicated. So if there's any sort of little gap or anything where it's in the polyline, polylines, even if there's a tiny little gap, it won't join them together, and so this is where it'll pick up those little tiny distances, right, to kind of join it together. So we're just gonna leave 0 and hit enter, and we're gonna again enter the option that we want to. Sorry, no, we're not. We already did that. I got lost in the command. I hit join. I hit enter for the fuzz distance, and then down here it says 7 segments have been added to your polyline. So you know that you were successful in that. Now, it acts like, hey, you want to keep going? It's a continuous command, right? So not only did I want to join it together, but what if I wanted to add a width to it, right? So I could click on width now, and it will say, hey, what width do you want to have about all of these line segments that you have selected? I could say something like 2 inches, enter, and I get a really thick line. Okay, and again it says, hey, would you like to do something else on this polyline? And for right now we're not going to do that. So now that we're done, I'm just going to hit enter, enter, and I can, or escape, whatever, and get out of the command. Okay, so the two, you know, we have join and then we have the width that we can use. Width is really kind of a nice option because when you bring a line with a width like into SketchUp, it will allow you to extrude a solid, right? So push-pull a solid. It's also nice when you're doing things like area takeoffs where you need to outline an area. So your client says, you know, how much tile flooring do we have? And you get the floor plan in AutoCAD, and then you trace the areas, right, with tile flooring. And you say, well, we've got this area, and this area. All together we have 4,000 square feet, right? So that's pretty helpful for that. I actually, funny enough, I use polyline with a width all the time. Creating blocks, title blocks. I'm trying to think of all the different uses because I actually really use it all the time. But you'll find uses for polyline with a width all over the place, okay? You ask, well, what if I created a width and then I don't want a width on there again? How do I undo that? Well, you can explode the polyline, and that will not only break it apart, it will break the width. It will take it from a 2-inch width, like I have defined here, to a 0 width again, Okay, so I can X explode, and it takes it back. I'm going to redo that and show you another way to do it. Hopefully it'll redo it. Oh shoot, it won't redo it. The other way that I could have undone it is, here we go, is by typing in pedit, enter, okay, clicking on multiple, or you're going to notice in a lot of AutoCAD commands how there's a blue letter in each of these options, right? So I can click on it, or I can also type M, which is the blue letter, M, enter, and then I can select my objects. When I'm done selecting, I hit enter. And now if I wanted to change the width back to 0, I could click on width, and I could type 0, enter, and it takes it back to 0, right? So pretty easy. But really, pedit is about manipulating your polylines, okay? It's not a hard command, but you can get lost in it pretty easy, so just follow all the prompts as you're working through it, right? So pedit, enter, M for multiple, enter. I select my objects. When I'm done selecting, I hit enter, and then I pick an option, join. Enter, enter, and I'm done. Okay. All right, so we've talked about polylines, we've talked about exploding, we've talked about pedit, which joins them all back together. A little bit more on lines. Let's talk about LT scale. And hold on, let me make sure I get everything here. Oh, and I want to do one more modification command today as well. Okay. Well, in fact, we're going to do the modification command first because it really relates to polyline. I'm going to show you offset. All right. So the idea behind polylines is that a polyline is one long continuous segment, and that makes it easy to perform modification commands on these polylines, right? As I showed in this example, when I use the offset command, it offsets the entire polyline, right? So there's no cleanup, okay? So I'm going to come up here to polyline. The shortcut command on the keyboard is PL. I click on polyline, and I draw some shape. Click, 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 escape. There's my polyline, right? All right, so one of the modification commands we're going to learn today is called offset. And offset is this little guy right here. And offset will allow you to create a copy of, for example, this polyline, an exact copy of an object at a specific distance away from it. So if I, for example, this is a floor plan and I want to draw a wall width. It's 6 inches away, right? I could click on offset, click. Down at the command line it says specify the offset distance. So I could type in 6 inches, enter. And I'm just going to hover over the object and click on it to select it that I want to offset. So I click to select, and then I'm going to move to the side that I want to create the offset, right? We talked about offset. Did we talk about offset already?
Yeah.
Right? Okay, sorry. In my notes here it says to review, and I didn't remember actually going through it, and then, sorry guys, we learned it in Revit. So I'm like, did we already do offset? Okay, so we'll review it. But so you know about offset then, good. But this is a really useful tool for offset, right? Because the polylines are all, they have integrity essentially. So you know about offset. Okay, good. So polylines will help you offset objects. Let's talk about LT scale with regard to objects, okay? This is something that is related to layer, but also to lines, and something that you'll have to start paying attention to, especially as we get into drawing actual geometry, actual space, like floor plans or site plans or different things like that, right? You're gonna have to pay attention to LT scale, which is line type scale. I'm going to remind you in the layers dialog box, I'm going to create a couple more layers here. Click, click, click. I'm going to name this layer something like wall. You know, we'll make it proper, right? A-wall. And we'll give A-wall a red color. Click. Okay. And then here under line type, instead of it being continuous, I'm going to click on that and I'm going to make it a hidden line type. So I'm going to click on load and I'm going to go to hidden. Okay, hidden is a dashed line type. I'm going to hit OK. And I'm going to click on that and hit OK. So now my line type for A dash wall is hidden. Let's create another layer here. We'll call this one A dash property line, PROP. And instead of continuous, I want that to be, I'm going to load a line type, maybe something like center. So it has a dash and then a line. Well, actually, let's do a dash and then a dot. Let's see. I'm looking for, maybe that is the one I'm looking for. Well, we'll do center. We'll do center then. So I'm going to choose center. Oh, I think I'm looking for this one. Dash dot. That's the one I want. So dash dot right there. Okay. I'm going to hit OK. And I have my dash dot. I click on it. I hit OK. And now dash dot is associated with a dash property line. Okay. And by now you all know that what that means is that if I draw a line and I use one of those layers like a dash property, whether it's a line or a polyline, and I hit escape to draw that, I get a pattern with that line, right? So the line is still, it has integrity, it has a start point, an end point, and a middle point, right? And then it has this pattern associated with it. And patterns in drafting and AutoCAD mean something, right? So a hidden line type, like just a plain old dash line type, that means that something is either going to be demoed or that it is above or below the floor plate, okay? Something like a center line like this means property line, okay? Let me draw another line. We're going to go to, was it wall that I changed the, yes, okay. So walls don't typically have a dash line weight associated with them unless they are being demoed, of course. But we're just going to do this for the sake of argument today. I'm going to draw another line here using a hidden wall type, or a wall line type. And I see it's dashed. Great. Now the problem with both of these lines is that when I zoom out, right, the lines appear as if they are almost solid, okay? And you're going to run into this problem a lot in AutoCAD where lines that you've associated a line type with, like a dashed or center line or whatever, they appear solid in different applications, right? And the reason that they appear solid in AutoCAD is that AutoCAD is really kind of a big workboard, right? And so it doesn't really distinguish between tiny little lines and big gigantic lines. It's kind of uniform, it's generic, right? And so when you're trying to print things at different scales, big long lines in model space kind of look like they are somewhat solid, and maybe smaller little lines look like they have a dash to them when they both have the same pattern. And so there is a factor that will kind of even those things out in model space, and it's called line type scale, okay, LT scale. And it's an input, it's a number. It doesn't, let me just say this, and it sounds kind of weird to say, but it doesn't mess up your model space, right? So this is something that you will change frequently, and it's fine to do that. It's not going to mess any of your geometry up. It may change the way that you view dashed lines, okay, in your model space, but it's not going to change any of your lines physically, right? It's just how you're going to be viewing them. And you can change it all the time, and it doesn't really matter as many times as you need to, okay? So line type scale, let me show you what it does. Let me change it to something like 90. When I change my line type scale to 90, it essentially allows you to view these at a different scale. So, so the lines appear appropriate for the scale that I'm going to be using. All right. The general rule of thumb is that the line type scale is going to equal half of your scale factor. So if you want to print these objects in model space and you measure them and you determine that, you look at the very back of your book and you determine that, for your sheet size and for the size of the page that your scale is 1/4 of an inch is equal to a foot, right? The number right below that, scale factor, 48, that's your scale factor, that's the zoom factor we talked about in here. So your LT scale is in general going to be half that number, okay? And it's a toggle. So if I'm setting my line type scale because my lines don't look correct when I go to print, I type LT scale, enter, and I type in, if my scale factor is 48, I type in 24, enter. And that line type for viewing is appropriate if you printed these two lines at 1/4 of an inch is equal to a foot right now. Okay. Now, I'm going to put LT scale up there as maybe one of the most finicky things in AutoCAD, because sometimes it works and sometimes it doesn't, and sometimes it does work, but not with the general condition, the rules that I've given you, right? So I say, in general, the LT scale should be half the scale factor. And you do that and you think, I did it correctly. It is not working, okay? My best advice with LT scale is to try the, said method first. So always go to half the scale factor. And if that doesn't work, do half again. So if 24 doesn't work, try 12. And if 12 doesn't work, use 6, okay? And if 6 doesn't work, use 3. And if 3 doesn't work, try 1, right? And just kind of grade down until you get your LT scale to work. It's not gonna mess anything up, right? It's just how you view your lines, okay? And it's a fluid thing, so we're always constantly changing it. All right, so for LT scale, right, I'm gonna just do I'm gonna switch to paper space just because I can move quickly in paper space when I'm printing, but I just wanna show you what happens. So don't worry about paper space itself, okay? But do you see how those lines look solid when I wanna print them, okay? I'm gonna engage model space. LT scale. Well, in fact, first let me just determine my scale. I'm gonna scale this, you guys, when you see how I scale it, you're gonna be like, that's so easy. I don't ever wanna use model space again. Here's how we scale paper space. Done, right? So I just scaled this paper to 1/8 of an inch is equal to a foot. And that means that my scale factor would be 96. And half of that is 48, right? So my LT scale should be 48. And of course it didn't work. Hold on, let me change something else. Oh, it's really not working today. Oh, let me go back here. We'll change it in here. Sometimes it's finicky where you have to change it in model space. So LT, scale, enter, 48, enter, and if sometimes too in AutoCAD we have what's called a regen factor, R-E-G-E-N. If you make a change and it doesn't work immediately, you can regenerate your screen by typing R-E-G-E-N, enter. Nope, still doesn't want to work. Well, there's a perfect example of it not working, right? Let me make a new viewport. There we go. It might have just been my viewport. So let me change this to 96. Okay, so there, whatever reason my viewport was finicky. So I changed this to the scale of this viewport to 96, and now those line type scales are appropriate for 96, right, which is 1/8 of an inch. And you're going to start finding this same topic happening a lot in AutoCAD, meaning we are going to start thinking about our text in terms of the scale we're using. We're going to think about our dimensions in terms of the scale we're using, and we're going to think about our lines in terms of the scale factor we're using, right? Because we want them all to be appropriate and look right for the size of scale on the page. So if I came back here and I changed my LT scale to something really large like 360, which is very far from 1/8 of an inch, and I went back to here, you see how the line types are very far apart. This one very much doesn't read, right? And it's not appropriate for something that's scaled at 1/8 of an inch. It's the line type dashes are way too big.
So when you're scaling lines, it scales all the lines in your drawing?
Yeah, in model space, yes.
Model space.
And it scales them all, but again, it's one of those things where when you do it at a different scale, then it doesn't really matter. Like, it just kind of regenerates them. And so you're probably thinking, well, what if I do 3 or 4 different scales, right? Do I have to change it every time? We have something that will help with that, another thing we'll talk about later. But in general, right now we're only printing one thing at a time. So you could change the LT scale, print one thing, go to the next one, change the LT scale, print the second thing, go to the third thing, change the LT scale, and then print that third thing. And it's completely valid to do it that way for now. For now. Okay. But this is something it's just the bane of my existence, honestly. I hate this when this kind of stuff happens in AutoCAD. Because you are constantly changing it, you know, and you want things to print correctly. And this is always one of those things where your client is like looking over your shoulder and you're like, hold on, I'm just trying to get the LT scale to work, you know. But you know, we'll work on it. But the general rule of thumb is the LT scale is half the scale factor. If that doesn't work, do half again and then half again and then half again until you get it to work. Okay. Okay. Trying to decide, how are your assignments going so far? Good. Trying to decide if we should get into site plans today. Yeah? Okay. Let me we'll do this. We'll introduce the idea of it, drawing a site plan and how to use surveyor units, okay? And then next time we'll work on the same topic, okay? So let me just get to that point. 1 second. Ooh, we're almost to text. It's very exciting. Okay. All right. Now, polylines are great for drawing site plans at this point. And I say that because if you look in your book at the assignments that are going to be coming up, like, for example, in my book on page, let me find the site plan. In my book, it's page 2-20. You're going to be drawing some site plans. And this, you know, this is something that you know, civil engineers will do all day long, right? Architects will do it quite frequently, but not all the time, right? But it makes sense to know how to do it, especially if you're going to end up working on your own, because, you know, architectural site plans are required when you submit for permit, you know, through the city. And sometimes you have a civil engineer, sometimes you don't, sometimes you have a survey, sometimes you don't. But whether or not you're manipulating a survey you already have, or you have gone down to the city and purchased the plat and you need to redraw it, you need to know how to be able to do it, right? So as an engineer or as an architect, this is something that you're going to be working with. So let's talk about site plans, right? We've got this kind of diamond-y shape site plan that we'll be working on as part of an assignment. So let's talk about how to draw them. Polylines are really great for drawing site plans because you can draw them all in one continuous piece, and then you can offset them for to illustrate easements or, you know, whatever you need to illustrate on them. Okay. I'm going to close this. I'm going to close this, and I'm going to open up just a blank drawing. There we go. Okay. And we'll talk about site plans. The first thing that we need to think about when we talk about site plans are the units that they're drawn in, right? We're kind of switching gears here. We go back and forth between architectural and decimal, and we'll integrate surveyor units in here, essentially. But site plans are drawn in decimal format, right? So we're continuously going back and forth. So whenever we start a drawing that has a site plan associated with it, you're going to make sure that it is drawn in decimal format. So I'm going to type in units, enter, and site plans in and of themselves are not that difficult to draw. I think the hardest thing is, number one, remembering that you have to be in decimal and surveyor units, and the second hardest thing is that when you draw in decimals, it's essentially a 1/12 of the size of an architectural drawing, right? And so when we draw site plans, as an engineer, civil engineer, you draw them and they're how you need them. But as an architect, if you get a civil site plan from an engineer, it is 12 times too small. And so you have to scale it up by a factor of 12 to make it usable. So, you know, just making sure that the drawing is in the right units, and then remembering that when you use it architecturally, you have to size it up by a factor of 12. Those are kind of the two hardest things about site plans, okay? We'll go over that. All right, so first thing, we're going to make sure that our decimal is set, and we're going to make sure that we have at least to I think the book says to 2, but I think I'm going to take it out to the 3rd decimal point for precision. So we'll take it out to the 3rd decimal point for precision. And then the type of angles we're going to be using are surveyor units. And our surveyor units won't function correctly if we don't change the precision from that to this. And I can't even quantify what, for surveyor units to what that means, but I know it has to be there. So we have to be able to show a direction, degrees, minutes, seconds, and the second direction, the bearing, essentially, right? But I don't know what that means in terms of precision. So here are our settings for surveyor units. All right, I'm going to hit OK here. Looks good. Okay. Now, surveyor units, let's talk about surveyor units, and I don't pretend to understand how they function exactly. Those of you that are engineers might be able to better inform us, right? Although during the summertime, I had a student in here and she worked at a city-county building in the land department, so she kind of explained what all these mean, but they're still quite confusing. So if I have a surveyor unit, I'll have something like north, this is not very dark, north, there we go, 16 degrees. We'll do like 54 minutes and 88. It doesn't even sound right coming out of my mouth when I say, I'm like, that is a foot and that is an inch. That is not a minute or a second, right? And then we'll have another bearing, right? So that is kind of the format of a surveyor unit, all right? So we have a direction, which is north. We have a direction on the end, right? We have degrees. We'll just write it out. Degrees, minutes, seconds. Okay. And so this last semester, this woman said it had, and maybe, does anybody know? Who are the civil engineers in here? Anybody wants to admit, right? Can you explain the degrees, minutes, seconds? No? Not, okay. So she said it had something to do with like the quadrant of the land and about how you bear north and how it rotates. Anyway, I couldn't explain it. But this is how you're going to input it essentially, okay? And you need to understand the format. So we have degrees, minutes, seconds, even if we don't necessarily know what all of those are, right? I know it has to do with longitude and latitude and angles, but can't quite explain it. In AutoCAD, when we input it, we are gonna, and of course we're gonna have a dimension out here. And then we're gonna have this bearing. But essentially we're gonna have a dimension, and I'll make one up, like 1.78. And this is really kind of a polar input, so it's kind of complicated. You're gonna have a dimension, right? And we're gonna have so we're gonna have at 1.78 at an angle of, and then we're going to do something like north 16 degrees, 54 minutes, 88 seconds west, essentially. So our format is going to be kind of polar in nature. If you've already started, it's going to be somewhat relative in nature. And then we don't really use the degree symbol. We're going to use the D instead of the degree symbol, okay? So it's kind of this long string of terms that we use to create surveyor units, okay? Okay, so let's talk about how we do that. Let's see, in your book, we have, mine at the top of the page says drawing site plans, and it's on page 1-62. Yours is probably around there somewhere. But with that one, let me just write up here what I'm going to be doing, because I'm going to erase this and we'll just type it into the command line. But if you can't find it in your book, I'm going to type.
In the new book, it's 1-58.
158, okay, so 1-58. And we're going to do at 158.21 at an angle of south, 86 degrees, 43 minutes, 0 seconds east. Okay, so this is what we're going to be typing in to create our line from our surveyor unit. Before we get into that, though, I want to make something else a little bit evident to you. So if we have north, and we have east, and we have south, and we have west, I want to show you, right, this is a southeast bearing. So that means that if I draw that, it's going to move in this direction, southeast, right? And the line's going to go like that. This isn't to say that I also don't have the exact same angle that goes northwest, okay? But the difference between these two is not the bearing. They have the same kind of orientation as far as, you know, the angle of the line, okay? But this one will go from here southeast. And if I were to put this, create this exact same bearing and do northwest, like that, okay? It would be the exact same line, but the bearing would start here and move in that direction, okay? Sometimes you'll see that happen in your drawings where you have maybe a bearing that says southeast, but in reality it goes northwest, right? So it's, the line goes like this, but you get a bearing that says southeast. So it's the exact same line, but it goes that way. And you could get, you know, the northwest bearing by using this exact same line, just kind of moving it down to here, if that makes sense, okay? It might not make sense until it actually happens to you, but I do want to make that point, right? The southeast bearing is exactly the same as the northwest, it's just opposite, okay? All right, so let's talk about drawing these. The hardest part about drawing these is just trying to make sure you get all the input correct in the right sort of syntax. So number 3, it says, you know, basically using polar coordinates, we're going to draw this surveyor unit line, and it's the 158.21, right? So to create this, this first segment, I'm going to click on line or polyline. You can use either one. Polyline is nice because you get one continuous line when you draw your site plan. I'm going to click on polyline. I'm going to click to start, and I'm going to type that string of text at 158.21 at an angle of, and it's just a little angle you use in polar input, south. I'm going to do capitals, south. I don't think it makes a difference, but I like to be consistent. 86 degrees, 86D, 43 minutes, 0 seconds east. So if you look at my screen, that is going to be the input. So I clicked and I initiated my first point, and I typed at because it's relative from my first point. 1.51 is a dimension, and we do not add the foot mark there. We just type 158.21. If you type foot, it won't work because we're inputting decimals. At an angle of south 86 degrees, 43 minutes, 0 seconds east. And I hit enter. Right? And escape, escape. We've got our line.
Hey, mine didn't work there.
Yours went different?
It didn't even draw the line.
Did you click first? So let's do it one more time. Okay. I click on line, I initiate my line command. I click to start. Okay. And I'm going to type at 158.21 at an angle of south 86 degrees, 43 minutes, 0 seconds east. It was probably just something you typed in wrong, honestly. So easy to do. Enter.
Well, it still didn't go.
It didn't? Did you initiate the line command first?
Yeah, I'm using polyline though.
Okay, escape. Okay, so do polyline again. You should be able to
That's what I thought.
click. Okay, type that.
Mine is saying 2D point or option key required.
That's what mine was saying.
Point for option. Huh,
6 degrees.
it's weird.
Yeah, 2D
see. So all, yeah, yours says units, right? Is it all this looks exactly like mine, right?
Mm-hmm.
Well, let's do this. Just close out of the drawing you're in, don't save it, and let's open up a brand new one and see if maybe there was, that's weird that, is it happening to anybody else?
Mine worked.
Just 3? Okay. Huh. Yeah, let's close out of the drawing and just open up a brand new one. And we'll type units, enter. It's gonna be decimal. And we're gonna go to surveyor units. That to me seems like kind of a unit error, which is,
Is that what it is?
but I don't, but your units were set correctly, so I don't, we're gonna go to that, hit OK, and try one more time, see what happens. So I click on, I'll even use polyline. I'm pretty sure I used polyline when I did it. Specify start point, click. I'm going to type at 158.21 at an angle of south 86 degrees, 43 minutes, 0. Do you have 0 seconds
Oh,
east?
okay.
Do you have your,
I know why it worked.
okay. Do you have your dynamic input on?
No, I didn't hit the shift before I hit the angle.
Oh, okay.
Shift angle. So it put in a decimal instead of it.
Okay.
So I think that's why mine's not working.
Maybe that might. But you, Jake, yours didn't.
Same thing. Just looking to see if I.
2D point or option. 2D point or option key. Here's the weird thing about that. So that seems like a unit error because it's saying, hey, you need to enter a keyboard or an input to get your second line. So it's almost like it's not recognizing it. 2D point or option keyboard. Let me type it in. We'll see what the error says. 2D point or error. Let's see. 2D point or error. What did it say? 2D point or error keyboard?
Yeah, keyboard recorder.
Yeah, see, it says the wrong unit type is selected. Oh, did you type, after you typed your I think I know what happened. Type it in again. So at, oh no, okay, you didn't type a foot mark after that, right?
No.
Okay.
No. So then south 86 degrees, 43 minutes, 0 seconds, east.
So at, yeah, no, it's perfect. Did yours work, Aaron?
It did.
It did,
Yep.
okay.
Mine's broken.
Okay, let me see your, give me that keyboard. Let me
Okay.
look here real quick. Okay, 58.
Does it just keep telling you to specify next point?
Yeah,
That's what mine's doing too.
you're doing too.
So, let's see. What am I missing here? Okay, we'll look at your settings here real quick. Your units looked okay. Decimal, we'll just take it to the 2. Surveyor units, precision, that looks good. Inches, okay, international, okay. That's it's a units error.
Yeah.
So that looks good. Set. Okay.
So that
Okay, so you type that. What is that?
What is going on?
I don't know. At. Okay, what is it again? 158.21.
158.21.
At an angle
At an angle
of
south
minutes is the foot mark,
Right.
and seconds is the,
I thought I was doing it right.
whoops, east. Yeah, I don't know, cause I saw you typing it in.
Yeah.
It looked perfect. You're not doing any spaces because if you did space, it would not.
It would end up with like
It would
pushing
enter. Yeah, yeah. So. Have you what? Sorry. I think your AutoCAD is just in general frozen. Maybe. Can you see that?
Yeah.
Okay, so. Huh, no, that's weird. We are having some weirdness going. You should just be able to click on it.
Maybe let's reopen.
Yeah, close it out and reopen it. But you said yours isn't working over here either? Okay, let me try again. So it is me. Oh, I just, okay. So click your first start point. That might be the problem. Did you click a start point? I did, yeah. Oh, okay. And then like that. Oh, take that mark out from these taxes. Oh. Okay. Who else? Anybody else have troubles? Okay. Did it work now that we've gotten it successfully saved?
But on the board, we do have a foot mark after.
Oh, that's not supposed, that's just, I think, left over, sorry, from
Oh.
something else. That was, no. Look, there's another one there. Somebody else was drawing little dots here. Valid point.
Now mine seems to be working now.
It works now? Okay.
I'm not sure what you did. Maybe I was switching the. I'm usually pretty good about that, but maybe
It looked perfect when I looked at it. I don't know what was happening with that, but
it's working now.
good. Okay, so that's how that is essentially it. That's how you're going to input lines for site plans, okay? So if we look at, for example, if we go to your assignment, right, which is on page one, mine is on page 2-20, which is this one, okay? If we go to that and we want to draw those, I'll draw a few of those. I won't do them all today, but you will essentially draw all of those lines, right? You will draw that outer perimeter, and then once it's all finished, if you use a polyline, you can offset it in the 20 feet that is required for the setback. Now, not that surveyor units aren't complicated enough, right? But once you finish with your surveyor units, because you use decimal, it's essentially in AutoCAD a 1/12 of the size it should be. So you are drawing it correctly using surveyor units. It is the right size, like if a civil engineer is going to be using it. But architecturally, which is how we're going to be printing these, before you are finished with it, you have to scale it up by a factor of 12, okay? And I think I might save that for next time, but I just want to get us going on drawing the actual site plan. And then next time we'll go over drawing it again, how to scale it up, and how to add curves to it, okay? So let's look at this site plan on page 2-20, whatever yours is. And if we look at that, you're going to see that you have a designation down in the bottom left-hand corner of that site plan that says POB, that's point of beginning. And that is where you all will want to start drawing your site plan from, okay? One thing about drawing site plans, and this is a really big deal professionally, when you have a site plan that you've been given, draw every single line, okay? And I mean that in terms of, like, you start here, you draw over, you go up and over and down, and then you think, I'm just going to connect it, right? Did you do that? But what happens if that bearing is off, right? And you've drawn it and you connect it and you think, oh, it's great. But in actuality, it's totally off or something. and then you've got people out working on a site that's the wrong size, or maybe it's smaller than it should be, and there's something wrong, right? Essentially, there's something wrong. You'd rather discover it on paper before they get out and they are building and moving and spending money and time and effort, and So when you're working with especially site plans, draw every single line. Now, I do know that this site plan, there's a tiny, tiny, tiny little error on it at the very end, too. You wouldn't even notice it unless you zoomed really far in. But at the point of beginning where it comes back together, there's just the slightest, tiniest little gap, okay? So if you've drawn it and you notice that, don't worry about it. Don't worry about it. But we will draw some of this in class, okay? All right, so I'm going to start drawing this. Okay, so the first thing it says is, like in the assignment, set your units to decimal, right? Which we have done. If you open up a blank drawing, that will be done for you, of course. Set your angles to survey units, right? So we'll just verify that that has indeed happened. Okay, create the proper AIA layer names for the property lines. So the correct AIA layer names for the property lines, if you go to look in your book on pages where all the AIA CAD layers are, which is back on page 155 for me. But if you look under civil, it says AIA CAD layer names. Under civil, we have C-prop, which is property line. And we have C prop easement, which are easements, right-of-ways, setback lines, and roadways. Or setback lines, not roadways. So C-prop and C-prop ESMT, those are going to be our layer names that we're going to use for property lines. So part of the assignment will be to create those layers. So new layer, C-prop. Property lines are going to be one of the thickest pen weights on your page. So we're going to make it red. And then we are going to use a border line type for the outside property lines, it says on the page. So I changed my line type from continuous. We're going to hit load. I'm going to go down and find border. There's border.
So, I'm sorry, if they don't specify which border, would you use just the first one that pops up?
Yeah. Okay, I click on border, I hit OK. I'm going to click on new, and I'm going to change or have another one, C-prop-ESMT easement, enter. And that one is going to be, even if you just look at the page, right, you may not know what color it is, but I can look and see that it's, very significantly lighter than the property line, so maybe it's 2 steps down from the property line. So we'll do green. And then this one is going to be use a hidden line type. So load, hidden, okay, hidden, okay. And we have our layers. So I'm going to change to C prop, which I just double clicked on it and it made it the current layer. I'm going to close that out. And it's time to draw. So I have the correct layer name, I have the correct line type, it's time for me to start drawing. I click on polyline, I initiate my first point by click, and I'm going to type at, okay, this is 158.21 at an angle of south, 86 degrees, 43 minutes, 0 seconds east. And I forget sometimes the at symbol, sometimes I put a foot mark in there because I accidentally forget, right? It's like you just have to kind of, cruise over, look over it again, hit enter. Okay, there's my, and it was kind of small, but that's okay, we're, you'll notice the line type dashes are kind of small, right? One nice thing that polylines have now that they didn't used to have, you have this little cursor mark at the beginning of the line, right? That just indicates where you started with your polyline in case you're tracing something, okay? I'll do the next one. So now we are at, let's see, 180.31 at an angle of north 18 degrees, 50 50 minutes, 00 seconds east. And you're probably thinking, well, does that 00 really need to go in there? Yes, it does. I think yes, it does. Always
Just do it.
type it in exactly as you see it, right? So
That's why we set those units on the angle, so that
Exactly.
all that information in there, so it needs all that information.
it needs it all. Yep, exactly. So precision, if you guys don't understand the idea of precision, it means that, so let's look in feet and inches, right? If you have your precision set to a 1/16 of an inch, and maybe you're drawing millwork details that have little round details that are an eighth of, or like a 32nd of an inch, right? Precision means that AutoCAD will only draw to that increment. So even if you type in 1/8 of an inch, if your precision is set to a 1/2 inch, it'll draw a 1/2 inch because it only goes to the smallest increment the precision is set to, right? So for surveyor units and decimals, we have to set them to a small enough precision that anything we type in it will recognize essentially. And so this you know, degrees, minutes, seconds, it has a certain precision with it. If we don't have that associated, it just, you know, essentially rounds to whatever increment. Okay, so I hit enter and that looks pretty good, right? Maybe I will just draw this whole thing. It's an easy assignment, right? At 185.18 at an angle of north 23 degrees, 27 minutes, 40 seconds west. Okay, that looks good. Enter. Good. And then we have the next one, right? We're just working our way around. And I'm going to type at 205.00 at an angle of south 50 degrees, 23 minutes, 15 seconds west. Go. And one final one is so tempting. You're like, oh, I'm just going to close it up. Don't do it. Right? You know, we are inherently set up with all of our consultants to have a good check and balance. So if one person doesn't find the mistake, the other person will find it, right? Because you're generating a lot of the same information. And so it's, you just redraw it, always draw it. All right, so, I made a mistake. So I escaped, I accidentally escaped and I got out of it and it's not a polyline anymore. And you're thinking, oh great, the world's come to an end, right? But it's okay. It's okay. We can just click on polyline and continue on. I can snap to that endpoint and then we'll p-edit it back together or join it, whatever you want to use, right? So I'm going to type at 201.36 at an angle of south 4 degrees, 24 minutes, 48 seconds east. Enter. Okay, so it's basically there. There's a tiny little, see that tiny little mistake, right? But we have our site plan here, okay? And, you know, I really would have liked it if I could have made it an entire polyline, but I couldn't. So using polyline or join, we're going to join this back together. We'll just use join in this case.
No, it came back perfectly. I don't have that mistake.
Oh, really? Oh. Huh. I don't know. So I'm going to click on join and I'm going to select all those objects and hit enter and it brings them all back to a polyline. Okay, so now we're back on track. Here's kind of the kicker, right? So we'll just go over it now and I'll repeat it again when we meet on Thursday, but these drawings are suitable for engineering, but for architectural we have to scale them up by a factor of 12 to make them usable, okay? So what that means is that if I want to offset that property line by 20 foot, right now, using a foot increment, it wouldn't be appropriate because I'm still in decimals, right? It's 12 times too small. And if I typed in a 20-foot offset, it wouldn't be the right size as it is, okay? So what I'm going to do now is I have to scale this object up by a factor of 12, and I only have to do it one time, okay? And if I needed to bring it back to civil decimal points, I would scale it down by a factor of 1/12, okay? So the way that I'm going to scale this object is I'm going to use the scale command, and it's right here, scale. I'm going to click on it, or you can type in scale at the command line, and it says select objects. I'm just going to select my objects, enter. When I'm done selecting, I hit enter. You have to tell AutoCAD when you're finished selecting, and it's going to say specify a base point. The base point is kind of where the object grows off of. Okay, so if I click in the middle, you see how, and it gives me a preview, see how it's scaled off the center? Okay, if I scale from this endpoint, you see how it kind of grows off that point, right? It's not a huge deal. Really, it's only affecting where it's going to lie in AutoCAD. So you don't have to worry too much about a base point, you just have to pick one. So I've clicked to establish a base point, and now it says specify a scale factor. So I'm just going to type 12, enter. Okay, and it scaled it up. Now, this, I think, is when students are first working with site plans, you think, did it scale it? I don't know if it scaled it. Maybe it didn't. I'm going to scale it again, right? So I guess, what would be a good way to mitigate that? Maybe a good way to mitigate that would be to draw a tiny little line next to it or something. And don't scale that object, right? So I'm going to type scale, enter, select my object, hit enter, pick a base point, click, and I'm going to type 12. So maybe that's a good idea. Maybe you draw just a little piece of something next to it, and then you scale it so that you can know graphically and look at it that it's scaled, right? Easy to, I don't know why I didn't think of that before, because I had students were scaling, and you know, it was the wrong size. So now we have our site plan and it's the right size, and now I can offset that line, offset 20 foot. Oh, but wait a minute. Okay, another problem. If I type 20 foot and I hit enter, that's not right, is it? So I'm still in decimal points. So there's a lot to drawing site plans. There's a lot of settings. You have to remember everything. So I'm going to hit undo. I'm going to change from decimal down here to architectural. Now offset, enter, 20 foot, enter, click, click, and there's my easement, and it looks perfect. Okay, we'll go over this again, like I said, on Thursday, because there's, you know, it's kind of complicated, but essentially the steps: number one, set your units to decimal and surveyor. Okay, make sure the precision is correct. Draw your site plan. When you're done drawing your site plan, scale it up by a factor of 12. Okay, once you've scaled it up by a factor of 12, you are then in essence in architectural units. So you're going to change over to architectural units and then create any offsets for easements or whatever. Final step here, I'm going to grab that easement and change it to the right layer. Now here's something interesting. Do you see that we have them on the right layer, but the line types aren't reading, of course, right? Yes. So you think, well, okay, I need to change my LT scale. Great. What is the scale factor of this drawing? I don't know. So you have to figure out the scale factor first, right? And then you can change the LT scale. So even regardless of whether or not you are, you know, printing in model space, you still have to know the scale factor. So it's good to learn this process. So I'm going to essentially kind of set this up to print without setting it up to print, because I need to figure out the scale factor so that I can print or get the lines reading the way they should. So I'm going to distance measure this line. Okay, and it is 268 by 356. $268 by 356. So I look at my scale factor chart at the very end of my book, and let's just say we're printing on 11 by 17. It's pretty good size. And 268. So it looks like our scale factor is 1 inch is equal to 30 feet, which is a 360 scale factor. Okay. So if I wanted my lines to read here, I would type LT scale and type in 180, which is half the scale factor, and there we go, right? So my lines now are showing dashed. Okay. I know there's a lot of steps in this, and it doesn't you probably fully won't remember them all for a while, honestly. but we'll go back over these again. Okay, any questions on site plans so far? Okay, so I haven't published your assignments yet. Let's see here. One of your assignments will obviously be to draw this site plan. Yes, that is going to be it. Draw that site plan. So I'll publish this assignment, but you are going to be drawing, it says page 220, but it's different in your book.
It's the same
It is 220? Okay, so maybe I changed that one because mine's 221. Or no, mine's 220. Huh, okay. So you're going to be drawing that site plan as an assignment, right? And then next time there will be the next set of site plans you're going to be drawing will be the ones subsequent to that, which will have curves. Let me just give you, if you want to get ahead, you can start drawing these ones with curves and you know, just do the best you can. Everything should be the same up until you get to the point where it actually does curve. Okay, so you could get ahead and start doing those, but I will. I'll set a you know, a due date and publish that site plan. Okay. We'll go back over this next time. We'll go over how to draw with curves next time. And let's see. Let me just pull up our schedule and make sure we are on track. Let's see. We are cruising through all of this. The 21st. Yeah, so next time we'll go back over site plans and then draw site plans with curves. And then next week we are getting into annotation. It's good. Good, good. Okay. That is it for today. Here we go.